we are going to represent real-life situations using exponential functions. So here is our learning outcomes. At the end of the lesson, the learner is able to represent real-life situations using exponential functions. And these are the lesson outline. First, exponential functions. Second, population, half-life, and compound interest. And the last one is the natural exponential function. Okay, so an exponential function with base b is a function of the form f of x is equal to b raised to x or y is equal to b raised to x, where b is greater than 0 and b should not be equal to 1. So it cannot be equal to 1 because once the base is 1, and any value of x that you substitute with x, still the answer is 1. So it will become constant function instead of exponential function. So just remember, our base should be greater than 0 and not equal to 1. Okay, so example 1. Complete a table of values for x equals -3, -2, -1, 0, 1, 2, and 3. For the exponential functions, y is equal to 1/3 raised to x, y is equal to 10 raised to x, and y is equal to 0.8 raised to x. Okay, we have a given function here and then we substitute the given values. So let's try to construct a table of values using the given values of x. So we have -3, -2, and -1, 0, 1, 2, and 3. Now we have first function y is equal to 1/3 raised to x. This is exponential because 1/3 is greater than 0 and our base is not equal to 1. So therefore, y is equal to third is raised to x and this is exponential function. So all we have to do here is to substitute -3 in our x. So since our exponent is negative number, just get the reciprocal, so it will become 3/1. So 3 raised to 3, that is 27. So same process with -2 and -1. So let's go proceed to 0. So 1/3 raised to 0 is 1. So any number that is raised by 0, that is 1. Next is 1. 1/3 raised to 1, that is 1/3. So same process for number 2 and 3. So 1/3 raised to 2, that is 1/9. And 1/3 raised to 3, that is 1/27. So let's proceed to the second function. So the second function that we have is y is equal to 10 raised to x. So y is equal to 10 raised to x. Let's now substitute the values of our x. So 10 raised to -3, so that is 1/1000. Since our exponent is negative, let's get the reciprocal of it. That will become 1/10 raised to 3. That's why it is 1/1000. Same process to -2. That will become 1/100. Okay, -1, that is 1/10. So 110 is raised to 0. The answer is 1. And 10 raised to 1, that is 10. Then 10 raised to 2, or 10 squared, is 100. Then 10 cubed is 1000. And the last function that we have is y is equal to 0.8 raised to x. So 0.8 is greater than 0 and not equal to 1. So therefore, y is equal to 0.8 raised to x is an exponential function. So now let's substitute the given values of x. So when we substitute, we can use scientific calculator to check your answer. So 0.8 raised to 2, the answer is 1.5625. And then 0.8 raised to negative 1. So since it's negative, get the reciprocal, so the answer is 1.25. 0.8 raised to 0, the answer is 1. And 0.8 raised to 1, that is 0.8. And then 0.8 raised to 2, that is 0.64. And 0.8 raised to 3, that is 0.512. So now let's have another example. So we have f of x is equal to 3 raised to x. Evaluate f of 2, f of negative 2, f of 1/2, and f of 0.4. So all we have to do is to replace our x with the given values. Positive 2, negative 2, 1/2, and 0.4. So if our x is 2, so f of 2, that will become 3 squared. So 3 squared is equal to 9. So f of negative 2, it will be 3 raised to negative 2. Since our exponent here is a negative number, get the reciprocal, that will become 1 over 3 raised to 2. And 1 over 3 raised to 2, that is equal to 1 over 9. Next, f of 1/2, 3 raised to 1/2. Let's evaluate 3 raised to 1/2. It will become square root of 3. Another, we have f of 0.4. So that will become 3 raised to 0.4 is equal to 3 raised to 2 over 5. So why 2 over 5? So when we convert 0.4 from decimals, so that will become 4 over 10. So get the lowest term of 4 over 10, that is 2 over 5. And then when we evaluate 3 raised to 2 over 5, that will become fifth root of 3 squared, and it will become fifth root of 9. Okay, so let be a positive number not equal to 1, that is 1. A transformation of an exponential function with base b is a function of the form g of x is equal to a times b raised to x minus c plus d, where a and c and d are real numbers. Now let's have example number 3. At t equals 0, there were initially 20 bacteria. Suppose that the bacteria doubles every 100 hours. Give an exponential model for the bacteria as a function of t. Initially, at t equals 0, so the number of bacteria is 20. At the start, the number of bacteria is 20, and then it will double every 100 hours. So after 100 hours, the number of bacteria is 40 because 20 times 2, that is 40. So after 200 hours, it will double again the 40, so it will become 80. So 2 squared, that is 4 times 2, that is 80. 40 times 2, that is 80. After 300 hours, the 80 will be doubled. That will become 160. So when we simplify 2 raised to 3, that is 8 times 20, that is 160. And then after 400 hours, this is now 320. 2 raised to 4 is 16 times 20, that is 320. In this situation, we can represent using the exponential model. Y is equal to 20 times 2 raised to t over 100. So we get the 20 is the initial number of bacteria. And then the 2, we get it because of the given, which is double. And then the 100, we get it of the unit of time. Now let us proceed. So we are now in the second lesson outline, exponential models and population growth. Suppose a quantity y doubles every t units of time. If y sub 0 is the initial amount, then the quantity y after t units of time is given by y equals y sub 0 times 2 raised to t over t. The half-life of a radioactive substance is the time it takes of half of the substance to decay. So now let's have the example number 4. This is another application of exponential function in the half-life. So suppose that the half-life of a certain radioactive substance is 10 days and there are 10 grams initially. Determine the amount of substance remaining after 30 days and give an exponential model for the amount of remaining substance. So we use the fact that the mass is half every 10 days from the definition of half-life. So let t is the time in days. Thus we have initially at t equals 0, amount of substance is 10. So let's have first a representation in a certain time. So at the start, the amount of substance is 10 grams. So it will be half-life after 10 days. So in 10 days, it's only 5 grams. So after 20 days, so 5 grams, it will be half and it will become 2.5 grams. And after 30 days, so it will become half again and it will become 1.25 grams. So therefore, the amount of substance remaining after 30 days is 1.25 grams. So in this situation, we can represent using exponential model by y equals 10. Again, 10, that is initial amount or initial number of number times 1/2. 1/2 because of half-life raised to t over 10. And 10 is the unit of time, that is the 10 days from the given. So let's proceed. So we are now in the exponential functions and half-life. If the half-life of a substance is t units and y sub 0 is the amount of the substance corresponding to t equals 0, then the amount of y of substance remaining after t units of time is given by y is equal to y sub 0 times 1/2 raised to t over t. A starting amount of money called the principal can be invested at this certain interest rate that is earned at the end of a given period of time, such as 1 year. If the interest rate is compounded, the interest earned at the end of the period is added to the principal. and this new amount will earn interest in the next period. The same process is repeated for each succeeding period. And now we are going to discuss about the compound interest. This is the last part of the second lesson outline. So compound interest. If a principal P is invested at an annual rate of R compounded annually, then the amount after T years is given by A is equal to P times 1 plus R raised to T. So we have here an example. Mrs. De La Cruz invested 100,000 pesos in a company that offers 6% interest compounded annually. Define an exponential model for the situation. How much will this investment be worth at the end of each year for the next 5 years? So using the exponential model, A is equal to P times 1 plus R raised to T. So our principal amount here is 100,000 and the annual rate is 6%. So since it is percent in percentage, we need to convert it into decimal, and it will become 0.06. And our time, the given time is 5 years, so it is equal to 5. So what we can do is substitute all the given values. A is equal to P times 1 plus R raised to T. So you can use that exponential model. So we get this is equivalent to 130,822 pesos and 56 centavos. So you can use your calculator to check. So A is equal to P times 1 plus R equals raised to T. So the equivalent of P is 100,000 times 1 plus the equivalent of R, which is 0.06, and then raised to time, which is 5. So it is equals 100,000. 1 plus 0.06 is equal to 1.06 raised to 5. So the answer is 133,822.56 centavos. An exponential model for this situation is y equals 100,000 times 1.06 raised to 5. The investment is worth 133,822.56 pesos. Okay, so next. So this is the last lesson outline in this lesson, in the lesson 12, the natural exponential function. While an exponential function may have various bases, a frequently used base is the irrational number e, whose value is approximately 2.71828. The enrichment in lesson 27 will show how the number of e arises from the concepts of compound interest. Because e is a commonly used base, the natural exponential function is defined having e as the base. So definition. The natural exponential function is the function f of x is equal to e raised to x. So now let's have the example of the natural exponential function. A large slab of meat is taken from the refrigerator and placed in a preheated oven. The temperature T of the slab T minutes after being placed in the oven is given by T equals 170 minus 165 E raised to negative 0.006 T degrees Celsius. Construct a table of values for the following values of T. So we can substitute the value of T 0, 10, 20, 30, 40, 50, and 60. So it says here to interpret your results. So round off your values to the near side. So what will be our interpretation based on the result data? So the slab of meat is increasing in temperature at roughly the same rate or the same way. So that's the end of the lesson 12. I hope you learned something in our report.